Hello everyone. So let's tackle our next problem with altitudes. Problem 7.23. Where do the altitudes of a right triangle intersect? Inside, outside, or on the triangle? How about an acute triangle? How about an obtuse triangle? So let's first start by making a right triangle. Now to do that we need a right angle. So let's see. There's an angle tool somewhere. Angle with a given size. And put it right there, 90 degrees. Alright, so we got our 90-degree angle. We don't really need to look at that. Okay. Now we just make the polygon. And now we got our right triangle. So, where are the altitudes going to meet at? Where is the orthocenter going to be located? Well, the orthocenter or the altitudes are always drawn 90 degrees to the base. So, let's say I take the vertex, why is this showing up? That's weird. Whatever. Alright. Let's take the vertex D. And I draw the line perpendicular to the base. So the base would be D prime and E, which is just the line DE, since that makes a 90-degree angle. So our first altitude, DE, the altitude ends up at E. How about D prime? If I said I'm drawing the altitude from D prime, then my base would be just DE, and we'll get the same thing. It just meets at E. So it seems like it's just going to end up at E. Well, what about the altitude drawn from E itself? Well, let's take our perpendicular tool. I'm going to draw a perpendicular line from point E to D prime. And yeah, it just meets at the same spot. So on a right triangle, oh, that's terrible. Oh my gosh, I can't even work with that. Okay. On a right triangle, the orthocenter, well, let's be specific, it is the intersection of the legs of the triangle. Intersection of the legs, or where that 90-degree angle is formed. So now we know where the orthocenter is for a right triangle. Let's try one of the other ones. How about an acute triangle? So we're going to make an acute triangle. No angle is bigger than 90 degrees. So we have this acute triangle right here. And let me just say, this is the first one we proved. Alright. Now, where are the altitudes going to meet in this case? Again, the altitudes are the perpendicular lines drawn to the base. So we have an altitude there from D to that point. Then our next altitude would be E to DF. And then our next one would be F to DE. And we get our orthocenter right there. Orthocenter H. So Acute triangles have orthocenters on the inside of the triangle. So now we know for acute triangles where the orthocenter is. Now the last one is obtuse triangles. So let me get rid of everything here. And let's make a nice obtuse triangle. So has a angle that's much bigger than 90 degrees. So, this is fine. All right. So let's draw the perpendicular line from D to EF. Whoops. Let's try that again. Perpendicular line from D to EF, from E to DF. Whoa. Maybe I should make it a little... Alright, you know what? This will be better. There we go. Still an obtuse triangle. But now I'm actually going to be able to see where they're going to intersect at. Alright, and then another one from F to ED. And, wow. So, in this case, the altitudes, the one drawn from E to DF, D to EF, all those lines that form the altitudes meet at the orthocenter here. Now, that is outside of the triangle, which is a unique property. So, obtuse triangles have orthocenters on the outside of the triangle. So, with all that said, that completes the problem for us. Right triangles, the orthocenter is the intersection of the legs. Acute triangles, the orthocenter is on the inside. And obtuse triangles, the orthocenter is on the outside. Fairly simple problem.